Hi everyone. In this lecture, we are going to see the response of undamped forced vibration using Duhambel's integral. So, lecture 1 and 2, we have seen responses of free and forced vibration, undamped and damped vibration. So, in this lecture, we are going to use Duhambel's integral to derive the response of the undamped forced vibration. So, general dynamic loading. So, this is the idealized system of undamped oscillator acted upon a arbitrary force. So, this is the mass of the system. This is the mass of the system. K is the stiffness of the system. X of t is the response. This is M is the mass of the system. This is the force acting on the system, and the K is the stiffness. And this is the force respective to the time period tau, and this is the force at time period. This total distance is time period t, and this distance is t minus tau. So this is the force, and this is a time period. So here we are all familiar that force equal to mass into acceleration. What is acceleration? Mass into dv by change of velocity with respect to the time. So this is nothing but f of uh, m dv by d tau. So here time period is tau. So m into dv by d tau, that is equal to the force. So incremental velocity dv. So dv equal to incremental velocity f of tau. F is the function of tau. Then d tau divided by m. So this is the incremental velocity. So response of undamped free vibration x equal to u0 cos omega t plus v0 by omega sin omega t. So this you can see the derivation in lecture 1 of the structural dynamics. When the initial displacement u0 equal to 0, the incremental velocity dv shall be considered as the initial velocity v0 of the mass at a time tau, and the incremental response here the term u0 equal to 0 and your response x equal to v0 by omega sin omega t. So the incremental response. So what is the incremental response? Dx of t equal to f of tau into d tau divided by m omega. So here v0, the v0 is nothing but the incremental velocity. So just substitute this incremental velocity f of tau d tau m into omega sine into omega t. Instead of t, we are going to use this t minus tau. So that is the incremental response dx of t by dt. So just integrate from 0 to t. So 0 to t, you will get the response x of t equal to 1 by m omega 0 to t f of tau into sine omega t minus tau into d tau. Thus, the total displacement of an undamped single degree of freedom system with an arbitrary load is given by x of tau is equal to u0 cos omega t plus v0 sin omega t. So this is nothing but a solution And this is a transient solution, and this is the response due to the applied force 1 by m omega 0 to t f of tau sine omega t minus tau in d tau. So the nature of forces. So we have derived the response of a arbitrary force. Now we are going to derive the response of the constant force. So constant force with respect to the time. So tau is the time, and the constant force, this is the constant force. So in the first lecture itself, I told in reality, um, developing or obtaining a constant force is impossible, but still we assume the force is constant. So this is m is the mass of the system, k is the stiffness of the system, x of tau is the response of the system, f of tau is the applied force. So the response of a single degree of freedom subjected to undamped forced vibration. So here the response is x of t equal to u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. When initial velocity and initial displacement were equal to 0, so this part equal to 0 and this part equal to 0, your response x of t is the response equal to 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. So just differentiate, just integrate uh, this sin omega t minus tau d tau. So just if you get confused with the sine, cos, integral and differential, plus or minus, if you get confusion, just see this graph. X-axis is cos theta, y-axis is sin theta actually. So then you can see minus sin theta and minus cos theta. So derivative means um, clockwise rotation, integral means anti-clockwise rotation. So you're integrating sine. So sine is integrated. So it is an anti-clockwise rotation. So you can see sine. If you differentiate, if you integrate the sine, you will get minus cos theta. So that is why. So here you will get omega t omega into here the variable is tau is the variable. So sine omega, there will be a minus, and here omega tau. So omega t is omega t minus omega tau. So this there is a minus here. So this minus and sine minus both will get plus. So you are getting f0 by m omega square cos omega t minus tau in the limit 0 to t. Just applying the limits uh, f0 by m omega square cos omega t minus t. So this will become 0, and your whole term will cos 0 equal to 1 actually. So cos omega t. So the cos term will be 1 actually. So you will get the answer f0 by m omega square. So k is nothing but m omega square. Omega is equal to square root of k by m. So x of t response equal to f0 by k 1 minus cos omega t. So the dynamic magnification factor or response ratio is nothing but x of t divided by x of static. So x static is nothing but f0 by k. So just this f0 by k get cancelled at the top and bottom. So your response ratio is 1 minus cos omega t. When omega equal to 2 pi by t, so t is nothing but 2 pi by omega. So if omega equal to 2 pi by t, the response ratio is equal to 1 minus cos into 2 pi t by t. So t is nothing but the time related to the applied force. This is the time related to the applied force, and capital T is the time related to the natural time period. Natural time period is related to natural frequency. Natural frequency is related to the stiffness and mass of the system. So this is the difference between the small t and the capital T. So next applied load is rectangular load. What is in the rectangular load? So here the system M is mass of the system, K is the stiffness of the system, X of T is the X of tau is the response, F of tau is the applied force. When the applied force uh, is applied to a time period Td, so this is the time period Td. If the applied force is applied for a time period of Td, then that type of load is nothing but rectangular load. So you have two types of responses, responses in phase 1 and response in phase 2. Response in phase 1 is nothing but the forced vibration. Response in phase 2 is nothing but free vibration. So the total time period is T, and forced vibration time period is Td, and the remaining period time period is T minus Td. So F is nothing but the force, applied force. Uh, when the time period is 0 to Td, your force is F0. When the time period is greater than Td, your force is 0. That is means free vibration. And phase, this is phase 1 and this is phase 2. This is phase 1 and this is phase 2. So response of a single degree of freedom system subject to undamped forced vibration. So the response is x of t equal to u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. This is nothing but Duhambel's integral. So for phase 1, when t is less than td, so when the t is less than td, the initial velocity and the initial displacement equal to 0. So in this case, the response is shrinked to x of t equal to 1 by m omega 0 to t f0 sin omega t minus tau into d tau. So the just simplify this formula, you will get x of tau equal to f0 by k 1 minus cos omega t. This is for a time period 0 to td. So in the next phase, that is a free vibration, how to find the response is coming in the next coming slides. So x of t equal to f0 by k 1 minus cos omega t, and here the x, when the time period t equal to td, so your x of td is nothing but the initial velocity. So we have derived the response. So this is our response forced vibration, that is phase 1, that is forced vibration. When you when the time period t equal to td, that is the initial conditions or initial or boundary condition to be applied for the next phase 2 free vibration. So dx of t, just differentiate to a time period t, and you will get f0 by k omega into, so here it is cos. When the cos is differentiated cos is differentiated, you will get minus sign. So already here minus is there, so the minus minus get plus. So f0 by k omega in this sine omega t. So just substitute when t equal to td, so you will get v0 equal to dx of td by td dt, that is equal to f0 by k omega sine omega td. So v0 equal to f0 by k omega into sine omega td. After substituting the initial condition, so initial displacement and the initial velocity, so we have calculated the initial displacement. From where we have calculated, so we have derived the response up to time response up to a t is less than or equal to td. So we have derived the response and we have substituted the time period t equal to td in the response x of t. So we have arrived at x of t, then we have find u0 and v0. So v0 and v0 we have calculated as so and so. Just substitute this in the free vibration response. What is the free vibration response? X of t equal to u0 cos omega t. T is substituted by t minus td. So here the t minus td, this is omega t. T is here t minus td. So u0 here it is v0 by omega in the sine omega t. So this is nothing but a free vibration response. So just multiply this cos omega t minus td here and here. Just multiply this, and here sine omega td into sine omega t minus td. So subsequently uh, we are getting f0 by k cos omega t minus td minus cos omega t minus td sin omega td sin omega t minus td. So this whole term looks like this. So when cos a plus b is equal to, that is cos a cos b plus sin a sin b, when minus cos a plus b equal to minus cos a cos b minus plus sin a sin b. So this terms looks like this. So this equation, so you can see minus cos a cos b. So this is a and this is b. So when you use a plus b, so omega t d plus omega t minus omega into td. So just these two terms get cancelled and you will get a plus b equal to omega t. So you are getting cos omega t. So already here minus is there. So we are getting plus cos omega t. Then already cos omega t minus td is already there. So this is your response of the free vibration. Your dynamic magnification factor is nothing but f0 by k and f0 by k get cancelled. So your response ratio is nothing but cos omega t minus td plus cos omega t for t greater than td. So this is your t greater than td. For the free vibration response, your response is cos omega t minus td plus cos omega t. When cos a plus cos a minus cos b equal to minus 2 into sin a plus b by 2. sine A minus B by 2. Sine minus A equal to minus sine A, then uh, your response. So this is we have found the response ratio. This is nothing but the response ratio. Uh, Nothing but x of t divided by x static. So cos omega t minus td plus cos omega t. So here you can see the formula here is cos A minus cos B is equal to uh, minus 2 into sine A plus B divided by 2 plus um, sine into A minus B by 2. There is a small correction here. The response is f0 by k cos omega t minus td uh, minus cos omega t. So the response is minus cos omega t. So this is the mathematical formula cos A minus cos B equal to minus 2 into sine A plus B by 2 sine A minus B by 2 sine minus A equal to minus sine A. So the response cos omega t minus td minus cos omega t equal to nothing but this is your A term and this is your B term. So your A term plus B term. So A is nothing but omega t minus omega td plus omega t. So your uh, here A minus B, you will get these terms get cancelled and you will get 2 omega t minus 2 sine 2 omega t minus omega td divided by 2 in the sine minus omega td divided by 2. So this sine term get cancelled by applying this sine formula. Sine minus a equal to sine a. So this sign gets go outside and this sign and this sign get cancelled and you get 2 in the sine omega 2t minus td in the sine omega td by 2. So you get uh, 2 sine omega t minus td by 2 in the sine omega td divided by 2. So when omega equal to t by 2 pi by t, then just substitute uh, this is minus cos omega t minus td minus cos omega t equal to 2 sine 2 pi by t t minus td by 2 sine 2 pi by t into td by 2 and it is further simplified and rewritten as 2 sine 2 pi t minus t small t minus capital T minus td by 2t into sine pi pi td minus t. So your response for t less than td is nothing but this all one. So as I said one, this is phase 1 response and another one is phase 2 response. This is forced vibration response. This is free vibration response. Actually, in reality, it is very difficult to uh, obtain this forced vibration response. You need very high efficient camera to observe this response. Uh, uh, Normally, this kind of responses will be measured in milliseconds. So it's very difficult to measure the forced vibration response, but we normally get the free vibration response. So this is the total response and it is a closed form solution. For triangular load, so this is the mass system and stiffness K and x of tau is the response for the applied force F of tau and the uh, applied load is a triangular load and you have two phases. One is forced vibration, another one is free vibration. Forced vibration is up to a time period Td and free vibration is T minus Td when the time period is T. Phase 1 is the response for forced vibration for limits 0 to Td. So equations of line for limits 0 to Td is nothing but f of tau equal to m tau plus c. So this is nothing but y equal to mx plus c. So m is nothing but a slope. So this is a negative slope. See, because the line is coming means in the negative direction. The slope is in negative direction. So tan theta is equal to opposite side by adjacent side f0 by td. So this is the horizontal distance is td and the vertical distance is f0 and the intercept c equal to f0. This is the intercept. So f of tau equal to minus f0 by td tau plus f0. So f of tau equal to f0 into 1 minus tau into td. So f of tau equal to f0 into 1 minus tau into td when t is less than or equal to td. This is the forced vibration. This is phase 1 and another one is free vibration response, that is phase 2. Here the force is 0 when the t is greater than Td. The response of a single degree of freedom subjected to undamped forced vibration. So here the response is using the Duhambel's integral x of t equal to u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega 0 to t f of tau sin omega t minus tau into d tau actually. When the initial velocity and the initial displacement is equal to 0, then your response further shrinks to x of t equal to 1 by m omega uh, 0 to t f of tau into sine omega t minus tau into d tau. So here the force, the f of tau is nothing but the derivation means the equation using the equations of line. We derived this forcing function f of tau equal to f0 into 1 minus tau divided by td. Then the response is nothing but x of t equal to 1 by m omega 0 to t and f of 1 minus tau divided by td into sine omega t minus tau into d tau. So this is simple mathematics. We are using the conventional formula for solving this response. So just substitute this, multiply this sine omega t minus tau and you will get the two terms. So f of 0 is kept outside. So f of 0 kept outside, f0 by m omega 0 to t sine omega t minus tau minus tau into sine omega t minus tau divided by td. So there are two parts actually. So here uh, uh, this is easy to differentiate integrate. So you know this is the sine term and you are integrating, so this is integral. So sine you are integrating, you will get minus cos theta. When you integrate the sine, you will get minus cos theta. So cos theta minus minus term get cancelled and if it is a differential, the omega will come at the bottom means the denominator. So cos omega t minus tau divided by tau 0 to t minus 1 by td in the 0 to t tau sin omega t minus tau into d tau. So here the tau is also variable, another tau is also there. So you cannot use simple integral formulas for providing for getting the solution. You have to use UDV method to solve this integral. So the integral 1 0 to t sin omega t minus tau, you get the answer as 1 divided by omega into 1 minus cos omega t. When in the integral 2, so this is like a UDV formula. So integral of UDV formula is used here to get the solution of the second integral. So UDV is equal to integral of UDV is nothing but 0 to t tau into sin omega t minus tau into d tau. So here what is your U? U is nothing but tau, and differentiate this, you will get du equal to 1, and your dv is sin omega t minus tau. So you for if you uh, integrate it, so sin, if you integrate you will get minus cos, so your minus minus get cancelled. So your v value is equal to, so you know the u value and you know the v, you got the v value. So using this u, v and du, so these three terms are required to get the solution of integral u dv. So uh, v equal to cos omega t minus tau divided by omega. So just substitute all the values in integral u dv. So this is nothing but uv minus integral of v into du. Just 1 minute. Yes, correct. Integral of v into du. So you know u value, u is nothing but tau, du equal to 1, 1. So remaining terms just substituting, um, you got tau into cos omega t minus tau. So here the integral is left 0 to t. So you have the 0 to t is left. By adding the integrals 1 and 2 and by substituting the response limits, you got the response. So uh, tau is nothing but t. So t cos omega t minus t, just you substituted this limits, uh, sin omega t minus t divided by omega square minus 0 into cos omega t minus 0 into sin omega t minus t minus 0. So you got sin t minus t, this is equal to 0. So your cos omega t is, this is also 0. So you this whole term further shrink to, so this term is already solved, that is 1 by omega cos omega 1 minus cos omega t, and this is the integral 2, this is integral 1, this is integral 1, and this is integral 2, integral 2. So further it is simplified as 1 by td t by omega. So this is equal to 1, and this whole term is equal to this sin omega t remains same, sin omega t. So it is further simplified as x of t equal to f0 by m omega into 1 by omega cos 1 minus cos omega t. This is integral 1 and this is integral 2. So it is further simplified as f0 by m omega um, uh, 1 by omega 1 minus cos omega t minus 1 by td in the t divided by tau minus sin omega t divided by omega square. So it is further simplified as this omega terms, here omega, this one omega, and here omega and another omega. taken outside, and you know k equal to m omega square. So omega is nothing but square root of k by m. So just substituting this formula, x of t equal to f0 by k 1 minus cos omega t minus 1 divided by td t minus sin omega t divided by omega, and you get further simplified as further rewritten as 1 minus cos omega t plus 1 by td into sin omega t divided by omega minus t. Just we take the minus outside. So your response ratio is nothing but 1 plus cos omega t. So here f0 by k, f0 by k get cancelled. So you got this term 1 minus cos omega t 1 by td sin omega t divided by omega minus t. So this is further rewritten as 1 minus cos omega t plus sin omega t divided by omega td minus t by td when omega equal to 2 pi by t capital T. This capital T is nothing but natural time period. Natural time period, small t is nothing but the applied force, means force forcing time period. Forcing time period. So x of t divided by x static t equal to 1 minus cos. Just substitute this omega by 2 pi by capital T, that is cos omega 2 pi by t by t, means small forcing time period by natural time period plus 2 pi by t divided by 2 pi td by t minus t by td. So you got the response for the time period 0 to td as 1 minus cos 2 pi small t by capital T plus capital T by 2 pi td sin 2 pi small t by capital T minus t by td. You will get the response for a time period 0 to td. Then the phase 2 free vibration response for a time period t greater than td. Here the equations of motion for a time period t greater than td is mx double dot plus kx equal to 0. The response of the undamped free vibration by applying the boundary conditions when t equal to td, your x equal to u0, when t equal to td, your response dx by dt equal to v0, when omega equal to 2 pi by t, the response is nothing but x of t equal to u0 cos omega t. So instead of omega, we put uh, 2 pi by t capital T. So instead of t, we are giving t minus td. So this I explained in the previous figure. Here cos omega t, sin omega t. So instead of omega, we are giving 2 pi capital T. Instead of small t, we are giving t minus td. So there are two boundary conditions. When t equal to td, the response is equal to the initial velocity. So just substitute x of t equal to, this is your response, f0 by k 1 minus cos omega t plus sin omega t divided by omega td minus t by td. So just substitute t equal to td and you get the values f0 by k 1 minus cos omega td plus sin omega td by omega td minus td by td. This whole term get cancelled. So here 1 and this one get cancelled. So you further simplified as u0 equal to f0 by k minus cos omega td plus sin omega td by omega td when omega equal to 2 pi by t. U0 is further rewritten as f0 by k into minus cos 2 pi by t td by t plus sin 2 pi by capital T into td divided by 2 pi capital divided by capital T into TD. By applying the second boundary condition, when t equal to 0, dx by dt equal to v0. So sorry, this when t equal to td. So the response t equal to td, then just differentiate this x of t with respect to time period t. So just substitute td f0 by k in the 0 minus omega. Cos is when you uh, uh, differentiate cos, you will get uh, derivative. So you will get minus sign. So already minus cos is there. So that is why plus omega sin omega td plus omega cos omega td. So again further you are differentiating sin omega td. So you know sin you are differentiating. If you differentiate sine, you will get plus cos. So omega cos omega td divided by omega td minus 1 by td. So this term get 0 get fade away. Then v0 equal to dx td by dt equal to f0 by k omega into sin omega td plus cos omega td divided by td minus 1 divided by td. You get the response v0 by k omega equal to f0 by k omega into sin omega td divided by omega. So this omega get cancelled, and cos omega td divided by omega td minus 1 divided by omega into td. So it is further rewritten as V0 by omega equal to F0 by K sin omega Td plus cos omega Td divided by omega Td minus 1 divided by omega Td. When omega equal to 2 pi, then V0 by K equal to F0 by K sin omega 2 pi divided by t into td cos 2 pi by t into td divided by 2 pi t into capital TD minus 1 divided by 2 pi divided by t into td. By substituting u0 and v0 in the response of the undamped free vibration response, then the response is equal to, so f0 by k u0 cos omega t minus td v0 by omega sin omega t minus td. So this is the response. So this whole term is nothing but u0, and this whole term is nothing but v0 by omega. So this is nothing but cos omega t minus td sin omega t minus td. This is the response. So you got the further response is further simplified as um, x of t equal to f0 by k minus cos 2 pi by t into td plus sin omega td divided by 2 pi by t into td into cos 2 pi t into t minus td plus sin into 2 pi divided by t into dd plus cos 2 pi divided by t into td divided by 2 pi uh, divided by t into td minus 1 divided by 2 pi t uh, 2 pi by t into td in the sin omega sin, that is 2 pi divided by capital T into t minus td is written here. So that is this is further simplified as just we have to multiply this cos term here and here, and this sin term you have to multiply at 3 levels. So that is what written here. So your this is cos term and cos term is multiplied, and sine term and cos term is further multiplied, and sine term and sine term is multiplied, cos term and sine term is multiplied, and this is a constant, and sine term is multiplied. So here you are having three terms. Here you have two terms, 1, 2, and here you have three terms, 1, 2, and 3. So you have total five terms, 1, 2, and here 1, 2, and 3. So these three terms, just rearrange this as follows. X of t equal to f0 by k minus cos 2 pi by t td cos 2 pi divided by t into t minus td. So you will get, the cos a cos b formula plus sin a sin b formula. So this formula I have written earlier. So then further the t by 2 pi td in this sin uh, 2 pi divided by t into td cos into 2 pi divided by t minus td plus cos into 2 pi divided by t into td into sin into 2 pi divided by t into t minus td. So this whole term can be further simplified. So this whole term can be further simplified. Then another one term, that is minus t by 2 pi td into sine into 2 pi t divided by t into t minus td. So using the cos a cos b sin a sin b. So this is a, this is b, and this is a, this is b. This is cos a minus cos minus cos a cos b plus sin a sin sin b formula needs to be used. Then sin a cos b cos b sin a. These formulas are used for solving and simplifying this trigonometric terms. So using sin a plus b, sin a cos b plus cos a sin b. So this one term, this is a term 1, is simplified uh, as, so a plus b, this is your a and this is your b. So your a plus b is nothing but 2 pi divided by t into td plus 2 pi divided by t into t minus td. So it is further simplified as sine into 2 pi divided by t capital T into small t. Then your second term, that is cos a plus b equal to cos a cos b minus sin a sin b. So this is your a term and this is your b term. So if your a plus b equal to, it's very simple. So a plus b is nothing but 2 pi divided by t into t. So you get minus cos into 2 pi t divided by t, capital T. So there are three terms, right? So your response is further very much simplified. This is first term, this is second term, and this is third term. So response is further simplified as x of t equal to f0 by k minus cos 2 pi small t by capital T plus capital T by 2 pi Td into sine into 2 pi small t by capital T minus sine into 2 pi small t divided by capital T minus Td by T. So f0 by fk is further struck down when you get the response ratio. This is your response ratio. So we get two responses, right? One is forced vibration response, forced vibration response. Another one is free vibration response for a time period 0 to Td, for a time period 0 to greater than T greater than Td. So x of t by x static, that is response ratio, is equal to 1 minus cos into 2 pi small t by capital T plus t divided by 2 pi Td into sine into 2 pi small t by capital T minus small t divided by Td. This is the response of forced vibration, that is phase 1 response. And another one is response is phase 2, that is free vibration. So response is 2 t by 2 pi Td into sine into 2 pi small t by capital T minus sine into 2 pi small t by capital T minus Td by capital T minus cos into 2 pi small t by capital T. This is the total response of the triangular load. So reference books, A.K. Chopra, Professor A.K. Chopra's Dynamics of Structures, a very good book. Then Structural Dynamics by Professor Mario Paz. Then NPTEL lectures are very much helpful for uh, deriving or arriving some solutions for the responses in the structural dynamics course. So I referred Professor Ria Catherine George of Hiroshima University, Japan, uh, Professor Meera Mitra of Aerospace Engineering of IISc Bangalore, Professor Srinivasan Chandrasekharan from Department of Ocean Engineering of IIT Madras, Chennai, Professor Sudeep Talukdar uh, of IIT Guwahati, then Professor Pradipta Banerjee from IIT Bombay. So Professor Sudipta Banerjee's lecture is the oldest lecture of structural dynamics. So more than 10 years back, uh, Sir has uploaded structural dynamics videos in NPTEL, and Professor Pradeep Kumar Ramcharla's lecture in NPTEL. These are all the NPTEL lectures I have referred for preparing this YouTube lecture, and also you can refer Sham series mechanical vibrations for solving problems. Thank you.